Section 9.6, Chord Properties. Our objective is students will successfully determine values of chords. First definition of the day is arc of the chord. This is a minor arc that shares the same endpoints with a chord. So on circle L here, our chord is segment JK, which means our arc of the chord is arc JK. Minor arcs theorem. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So, given circle C with the two chords segment AB and segment DE, if arc AB is congruent to arc DE, then segment AB and segment DE are congruent. Since this is an if and only if sentence, that means the converse is also true. So if segment AB is congruent to segment DE, then arc AB is congruent to arc DE. Our perpendicular diameter theorem. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. So given circle E, we have diameter AC, which is perpendicular to segment BD. Since segment AC is perpendicular to segment BD, that means it cuts both segment BD and arc BD in half. So we know that the two pieces of segment BD are congruent and the two pieces of arc BD are congruent. So arc BC and arc CD are congruent. Okay, so an example on how to use this. You can see that we have a circle and we have a radius that is perpendicular to a chord. First thing we've got to figure out is what do we have that we can move over. So we know since the radius is perpendicular to the chord that it splits the chord in half, and the 10.7 and this blank segment have to be congruent. So I can move that 10.7 over. Now notice, this shape is a right triangle. So we're going to use that to find our x. Pull that right triangle out. Ask yourself which side is the hypotenuse. So we always want to find that first, because when we have two sides known, we can use Pythagorean theorem. And we always want to start with the hypotenuse so we don't goof up putting things in. So we write it as c squared equals a squared plus b squared. So our hypotenuse is going to be the 11.9. So we end up with 11.9 squared equals 10.7 squared plus x squared. 11.9 squared is 141.61. 10.7 squared is 114.49. And then we have our x squared. Now to continue solving, we're going to subtract 114.49 from both sides. We get 27.12 equals x squared. We're going to take the square root of both sides, and remember we rounded to tenths is what the directions say, so x is going to be 5.2. A very similar problem, this is a very similar problem to the last one, except our radius that has the length isn't connecting, making a right triangle. So we want to go ahead and connect it to the end of our chord. And now we know all these pieces are all congruent. So now that is also 12.5. Our right triangle is here. However, our x is not on that right triangle. So let's go ahead and call that blank side on our triangle y. Okay. Move your triangle out and label it so you can see what's going on. We're going to solve for y first, and then we'll come back and solve for x. So our hypotenuse on this triangle is the 12.5. We square the other two sides and add them together. So 12.5 squared equals 11.6 squared plus y squared. 12.5 squared is 156.25. 11.6 squared is 134.56 plus the y squared. We're going to subtract 134.56 from both sides. We get 21.69 equals y squared. Now we got to solve for y, so we're going to take the square root of both sides. Remember to round to tenths. So we get y equals 4.7. Now back to our picture. We need to find x. Think about how you can find x. We know y plus x equals the 12.5. So then x is going to be 12.5 minus y. And our y was 4.7. So 12.5 minus 4.7 is 7.8. Your homework is the chord properties worksheet.